Hello, good people. Before you can even start, I just wanted to do graph interpretations to ensure that you master everything. So I'll just give you a quick summary of what you have to know, and we'll take it from there. So when it comes to graph interpretation, mostly for the ones of asking you for which values of x and stuff, if they will never say for which values of y, they will never say that. So always leave the y-axis and focus on the x-axis, especially your x-intercept. So let's say, for example, you must understand the basics of your Cartesian plane, right? So let's say you have your Cartesian plane like that, and then in that Cartesian plane of yours, this is the horizontal axis. I won't throw the y-axis because we won't focus on that. It's not important. So what I want you to understand from this is that if you have your graph being drawn like this, right? Sorry for the drawing that is not that smooth, but what I want you to focus on, if they ask you, let's say this was just f of x, right? So all these things, whether p of x, whether whatever of x, they all basically mean y, right? So if they ask you for which values of x is this greater than 0, what they are basically saying is that focus on the positive, like focus on above the x-axis, not the positive. When they're basically saying that f of x is greater than 0, they're basically saying that from the horizontal going up, right? That is the positives. From the horizontal going down, that is the negatives. Why are we saying that? I said that f of x, p of x, h of x, anything of x, it basically means y. So what they're basically saying is that give us the x values where y is greater than 0. So we know that y will be greater than 0 above the x-axis, and y will be less than 0 below the x-axis, right? I hope that makes sense. So it means that when they say where f of x is greater than 0, our focus is here. What they're basically saying is that give us the x values from which this graph will be above the x-axis. So let's say, for example, we had something like here, let's say our x value was -2, right? And then this side, let's say our x value was 4. So the x values where this graph is above the x-axis is from this point, right, going that way, and from this point going that way, because we can see that in between this graph here, it's below, right? This section is below, so we don't entertain this section here. What we want is the point where it's above the x-axis, and we know that it is from this point going that way, and from this point going that way. So what we basically do, we are basically saying that you take this x and you put this sign as it is, and you put this in order, right? So you put -2 here, put 4 here. So what we are basically saying here is that this graph will be above the x-axis when x is greater than 4, which is from this point going that way, and when x is less than 4, when x is less than -2, so which is from this point going that way, right? I hope that makes sense. If they said greater than or equal to, you will do the same, right? What that greater than or equal to, it simply means you include this point. You start at that point, you go that way. When they just say greater than, they basically say more than 4. So we won't include 4. It can be 4.1, it can be 5, but anything that is greater than 4. I hope that makes sense. And now that you understand that, it's the opposite when they say the values of x, for which values is this graph less than 0. So if they say it is less than 0, obviously the whole thing now changes. Now our focus will be below the x-axis, right? Our focus, our focus is now here, right? Our focus is now below the x-axis because that is where y is negative, right? So if they're saying, for example, let's say here we have 1 and here we have 4. So for which values of x is this graph below 0, we can see that the section that we'll be focusing on is this section here, right? So the section that we'll be focusing on is this section here, below the x-axis. So from there, how do you work with this one? Again, you put x in between and you put this you put the inequality sign as it is. Since it is facing that way, just put it as it is. This is just a simple method of not confusing yourself. Put 4 here and put 1 there, right? This only works only when they ask you with one graph, right? Sometimes they ask you with other graphs, but we get there. So what we are basically saying here is that this graph will be below the horizontal x-axis when x is greater than 1, but when x is less than 4, right? And then what they can do, again, those are the simple ones. What they can do, they can now give you 2 graphs, right? They tell you, they ask you, I mean to say, for which values of x is f of x, for which values of x is f of x multiplied by, let's say, g of x greater than 0. What they're basically saying, you don't have to confuse yourself. What they're basically saying there is that give us the point whereby both graphs are positive, because we know that when we have positive and positive, it gives us positive, and positive is greater than 0, which is what we want. Or you have where both graphs are negative. So it's negative and negative, which gives you positive. We know that when we multiply negative and negative, because this is multiplication side, when we multiply negative and negative, we get positive. So what we basically want, see, option 1 is that we want where both graphs are above the x-axis, or option 2, we want the point at which where both graphs are below the x-axis, so that when we multiply, the product is positive, right? I hope that makes sense. So what we are basically going to do in this type of examples is very, very easy, right? So the example is very, very easy. So let's assume that we had our straight line, right? Let's assume that that was our straight line. Let me draw a full Cartesian plane so that it makes sense, right? So let's say that is our Cartesian plane, and then we have our parabola as well, right? So we're given these 2 functions. So when you have something like this, let's say the one of parabola is the one which is f, and the one of straight line is the one which is function g. So they're saying the point whereby when we multiply, then the product is greater than 0. So where they are both above x-axis or where they are both below x-axis, right? So we can see that they are both above x-axis from this point, right? Because from this point to this point, you can see that this one, let me highlight it for you, it is below the x-axis, right? And when it's below the x-axis, you see that this straight line is above. So we don't want that point. Remember, we said we want a point whereby they are both negative or they are both positive. So this won't work, right? So now we then see again that from this point, right? From this point above, right? From this point going above, this is positive, this is also positive, right? So we will consider this point here. I don't know if that makes sense, right? But what I'm basically saying is that this point here, from this point going that way, we can see that it is favoring our situation. So let's say this point here was 3, and this point here, let's say, was -1, right? So we'd say when x is greater than 3, right? Because when x is greater than 3, that is when we have this. When x is greater than 3, from this point going that way, all the values that are coming from this point, it's 4 and the 5, whatever value is greater than 3. So from this point going to the right, this will be the situation because they are both above x-axis, right? And then we come to this point here. I want to make another example. Let's say we come to this point from here all the way to there. We see that this one is above x-axis, but the straight line is below the x-axis, so it won't work. So the only answer for this situation is this one, x is greater than 3, right? I hope that makes sense and you understood. Now, let's say we take the very same example, but now they are saying when x, the product of these two, where it is less than 0, right? The product of f and g, for which values of x where f and g will be less than 0. So when they say less than 0, it can only be one situation. Remember here we had two situations. Either we have where they are both positive or where they are both negative. For this one, you only have situation where the other one is positive, the other one is negative, or the other way around. But the other one needs to be positive and the other one needs to be negative, because positive and negative give you negative, positive and negative give you negative. So this is what we want, right? Less than 0 is negative, greater than 0 is positive. I hope that makes sense. So what we are basically now going to look for in our graphs is a point at which the other one is above the x-axis and the other one is below the x-axis, right? So like this point here, right? Like starting from this point of -1. You can see that from -1 going that way, the f is up above x-axis and the g is below the x-axis, right? So that will say when x is less than -1, right? When x is less than -1. So this is the correct, let me do this. This is the correct solution which we are looking for, right? When x is less than -1. Because from this point, the f is positive, the g is negative. Do we have another point where the other one is positive and the other one is negative? Yes, where? So this is the situation we have here, right? Check this from -1 to -3. This green zone I highlighted, right? You can see that the straight line is above, whereas the parabola is below. So we can even add to say that when x is less than 3, when x is less than 3, but it is greater than -1, right? Which is this point here. When x is less than 3, but greater than -1. So this section here, that is where the parabola is below and the straight line is above. So when we multiply those two, since the other one is positive and the other one is negative, when we multiply those two, the product will be negative, which is what they want here. I hope that makes sense. This thing goes, it applies to, it is the same thing that applies to the one of, these people try to confuse you. Good people, don't be confused. These things are very, very simple. Functions are very, very easy, right? And they don't trick you with anything. The only thing they change is values, right? So let's say, for example, you now see something like this. They tell you that give us the x, for which values of x is this true, right? They say f of x divided by this f of x divided by g of x is greater than 0. Still, it's easy. They are basically saying for us to have something divided by something and get a positive is either we are dividing positive with positive, then we get positive, right? Or we are dividing negative with negative. It's negative divided by negative, which will give us positive. So it's the same thing as the product. We want the point whereby they are both negative or the point whereby they are both positive. It's that simple. If they say f of x over g of x is less than 0, they are basically saying where the other one is positive, the other one is negative, or the other way around. But the other one is to be positive and the other way is to be negative, because we understand that when we divide the negative and the positive, we get a negative always. So that is what they will trick you with, nothing else at all. And then, or they can ask you maybe a point where f of x is equal to g of x, right? They can ask you a point where f of x is equal to g of x. This is for intersection, right? Where they meet. So let's say, for example, we had our graphs being something like, let's use something different, right? Let me use, what is this? Let me now use a hyperbola, sorry. Let me now use a hyperbola. So we have a hyperbola there, right? And we take this hyperbola, we put a straight line. So we can see that these two graphs, these two functions come in contact at two places, right? They come in contact at two places. Place number one, it's here. Place number two, it's there, right? So when they say give us this thing, they're basically saying that equate the equations and find the value of x, take that value of x and substitute it in one of those two equations, and then you find the value of y. If they said find the coordinates, right? But if they just said for which values of x do these two graphs intersect, then you basically simply do that. But if the values are given there, you just interpret from them, right? And talking about the hyperbole, but it's not really part of interpretation, but you must know how to find the equation of the axis, right? So what I want you to know is that this is the case, right? This is what I want you to know. We have two graphs. The one that is going up, this one, I'll label it 1, and the other one, I'll label it 2. Straight line 1, straight line 2. You always have two axes of symmetry. Not axes of symmetry, lines of symmetry with the hyperbola, because axis of symmetry is for parabola. So you always have two lines of symmetry. The one that is going up, the one that has a positive gradient, the equation of it is x is equal to x, always. This one, the equation is y is equal to negative x, but it's not always the case when they will say give us the equation of the line of symmetry and then you just write y is equal to x. Because remember, for you guys, you are now doing grade 11. You were introduced to horizontal shift and everything. So we know that the standard form for you guys, it's x plus p plus q, which is your asymptote, and p is also your asymptote, right? But when we focus here, you see now that back in grade 10, you just were given something like this, and you were only introduced to vertical shift. So that is why you would see that the line of symmetry won't change much. We would only change this value. But for you guys now, we won't write yes, you will write it like this, but what is your x value now? Your x value is no longer just x, it is x plus p. So your equation will be y is equal to x plus p plus q. This is the equation of the graph that is going up, that is ascending, right? And then for the other one, it will be y is equal to negative, in brackets, instead of just x, you now have x plus p. So it will be x plus p, sorry for the handwriting, x plus p plus q, right? This is the one that we use for when the gradient is negative. So you must know these two equations, right? This one is for the uptrend, right? This one is basically for number one, for equation number one, when the straight line has a positive gradient, and this one is for when the straight line has a negative gradient. I hope you're sorted and you'll be able to answer all those questions. So with all that being said, good people, I think you shouldn't have any problems, right? Unless if another thing they can trick you with is translations, right? If they ask you to translate graphs. So this is what I want you to know. If number one, they can say, give us the new equation when we now have f of x plus 2. This doesn't change anything, right? Don't be shaken. What you basically do, you take the equation of the function that you were given, and then you basically add 2. What this notation basically means is that this graph went up 2 units. That is what it basically means. And then another notation that you can have is when they say x plus 2 in brackets. So what this notation basically means, since it's f of x, it changes, it only has to affect the x-axis, right? So when it affects the x-axis, always when it's positive, it's going to the left, and when it's negative, it's going to the right. Don't say it's positive, it's going to the right. Don't follow the number line, right? It's the opposite. When it's positive 2, it basically means that it was shifted to the left 2 units. So if this was your original graph, you basically take it from this point, shift it 2 units. This will be the new graph here. I hope that makes sense, right? So another notation that they can obviously combine them, write it like this, and maybe write +4 here. What they basically mean is that this graph was moved 2 units to the left and 4 units up, right? And another one that they can use is, let's say, when they say f of negative x. So this is what I want you to know. When you reflect, the axis that you reflect on remains the same. If you reflect across the x-axis, the coordinate of the x-axis will remain the same. So let's say we were reflecting 1:2, right? You know that the coordinates always start with x is to y, right? So I'm saying that the one that you reflect across remains the same. So the other one will change. So when you're reflecting across the x-axis, instead of having 1:2, we will now have 1:-2, right? This x coordinate remains the same. The only thing that changes is the y, and the only thing that changes on the y is the sign. So always now, since they changed the x to negative, we know that they are reflecting across the y because they changed x. Remember, the one we are reflecting across remains the same. So since they changed this x from positive x to negative x, we know that they reflected across the y. If they do this, negative f of x, right, instead of just positive f of x, since, remember I said this whole thing means y, right? So since they changed y, we know that they reflected across the x because the one they are reflecting across remains the same. So here they reflected across the y because they changed x. Here they reflected across x because they changed y. So those are the notations. There's nothing fancy. Just take the original equation, substitute it with the notation that they put there. If it still doesn't make sense, please let me know. I'll be more than happy to help. So with that being said, good people, I didn't want this video to be too long, but this is what I'll do. You can pause the video, try to do these examples. I'll give you hints here and there. And then, because one thing about maths is not theory. You don't study maths. So you're watching the video, this video of me explaining everything. You don't gain anything unless if you do something, right, to check if you really understand. So with that being said, let's check here. You are given the function, right? You're given these two functions there. F of x is equal to that. And another thing, when it comes to the parabola, you must know that you must be able to complete the square and be able to write it in the form of a multiplied by x plus p, all of this squared plus q. You must be able to convert it to this form because this q comes in very handy. Even in question 1, they ask you about the minimum and maximum value. So for you to find the minimum and maximum value, you must be able to convert these to this, so that you use this q. Q is the y value of the turning point, and it is your minimum or maximum value depending on where your graph is facing. So since this parabola is approaching the positive y-axis, this will be the minimum value. The turning point, the y value of the turning point will be the minimum value. And then if the graph was like facing down like that, y value of the turning point there will be the maximum y value. I hope that makes sense and I'm not confusing you in any way. So with that being said, obviously it is not a must for you to convert it back here. What you can do, if they gave you in this form, you can basically take the, calculate the x value of the turning point by using this equation, right, of negative b over 2a. And then once you use that, you take that and put the x value here and you find your y. The y value that you will find should be the same as this q, right? So it's up to you, but I always prefer going for the completion of a square, but it's up to you, right? And it depends on the marks and everything. So another thing, with all that being said, another thing is to always calculate your x-intercepts. You know that when you calculate your x-intercepts, you let y be 0 and vice versa. So with that being said, good people, the first question is saying that we must calculate the length of OA. OA, you can see that A is the x-intercept of the parabola, and it is also the x-intercept of Y. So either way, whether you find the y-intercept of G or F, you must find the one answer, which is supposed to be negative Y. So when they say length of OA, you can't say negative 1. There's no way length will be negatives. So you must just say 1 unit, right? Regardless, you don't put the sign. And then you must find OB as well. So we can see that OB is from the origin. O is the origin, 0 is to 0, going to B, and B, we see that it is the, this is the distance they want, and B is the x-intercept. So if you found the x-intercept of the parabola, obviously you will find the coordinates there, right? The length, I mean to say. And then now you're supposed to find OC. So OC is this length from there to there. So we can see that, what do we see about C? C is the point whereby the parabola is coming into contact with the y-axis. So basically what we're looking for is the y-intercept of the parabola. So if you can be able to interpret these things for people, you should be sorted, right? Nothing should be giving you problems. And then 15.2 is they're saying calculate the coordinates of D, right? Where is D? D is our turning point. We can see that D is our turning point here, right? D is this point, is our turning point. So calculate the coordinates of D. Obviously, you use the method that I just showed you. You use x is equal to negative b over 2a, find the x value, and then take that x value, substitute it there, and then find the coordinates of D. So the coordinates of D, if you are correct, you are supposed to get 2 is to negative 9. If you don't get that, then you have something wrong with your teeth, right? That should be the answer. And then the next question is calculate the length of EF. Where is EF, right? So EF is this length here, right? That is EF. So we can see that here, what you basically have to do, because this one looks a bit tricky, but that's always the case with mathematics, right? Things look a bit hectic until you do that. So what I want you to realize is that EF, when you want the length of EF, we are only now focused on the y-axis. It has nothing to do with the x. So if you can find the y, the point at which the, what to call, the point at which these two graphs intersect, because you can see that they intersect here. I want you to master these things. They intersect at that point. So if you can find the x value there, the point at which they intersect, so you can equate the two graphs, look for x, and then take that x and substitute it in either one of the two, right? So if obviously you're looking for the x value, when you equate these two, you'll say x squared, you'll say f of x is equal to g of x, because you're looking for the intersection. And then you put these two as they are, and then obviously you will come to a point where you will have two x values. The other one will be negative, the other one will be positive. Obviously the negative x value should be this side, so we won't take it. And then you take the positive x value, and then you substitute it in that equation, right? So you will find the coordinates of E, and the coordinates of E, if you're correct, it's supposed to be 6 is to 7. Yeah, it's supposed to be 6 is to 7. So basically, the length of EF is 7 units, right? Yeah, if you don't understand that, please let me know. And then calculate the maximum, right? These are the kind of questions I was telling you about. For you to find the maximum, it means the maximum of GH, right? Here you can see, right? I told you about the minimum and maximum when you are just focused on the parabola alone. But here they're saying find the maximum of GH. In this case, you always say top minus bottom. Top minus bottom, meaning that you say, what is the top? And the top is the straight line. So you'll basically say G minus F, right? G of X minus F of X, right? And then the equation is that should give you GH, right? Sometimes they give you the units to say that the maximum value of GH is maybe, let's say, 30 units. Find this and this, right? So just be careful of that. But here they didn't give us, so that will be GH. And obviously, GH will give you a quadratic. So what you'll basically do, you take that quadratic, you complete a square. At the end, you'll be having something like GH is equal to AX plus P squared plus Q, right? And then you take the Q value, that should give you the what do you call it? The maximum value, right? So here in this case, the length of GH is supposed to be 49 all over 4, right? 49 all over 4, that should be the maximum value. So if you don't get this, there's something wrong with it, right? Let me know. I will be happy to explain. So with the last before, second before last, right? So we have the range of f of x. So f of x is the parabola. So obviously, the range is just y is an element of real numbers, right? It's either you write it like that because it is all the y values are just there, but we have to be specific because it is, remember that we said the turning point was -9, right? So you can say y is greater than -9, right? And then, but you can't just say greater, it is greater than or equal to because it is included. It is from here going up. It is greater than or equal to -9, and then y is an element of real numbers, right? So that is that. And then with give the coordinates of the turning point, right? You see what I was telling you about. So before we can finish reading this question, what do we know about this one? We know that this function, the original function of the parabola that was given here, it is shifted 2 units to the left because I said when it is positive, it is going to the left. So since it is x plus 2, it is 2 units to the left. So if we take this and then we take it 2 units to the left, we initially said that the coordinate of D was 2 is to -9, right? So that is what we have here, 2 is to -9. So if we shift that 2 units to the left, it will be 1, meaning it will be 1 here. Sorry. It will be 1, 2, right? So it's like -2 here. So the coordinates will now be 0 is to -9, right? There's nothing fancy you have to calculate. And Aaron described the translation that took place. This graph was basically shifted 2 units to the left. There's nothing fancy there. So that is it for these questions. I gave you answers. You can be able to work your way out and find the answers. You can even screenshot so that you have the whole exercise and then you do it, right? So here's another one. You can work this one out, right? I want you to master interpretation. So master this one out as well. You can screenshot, pause the video, then work it out until you find all the answers. And then I have the last one for you, which is this one here, right? So I just tried to find examples where you have different functions. So with this one also, you can just pause the video and screenshot, right? Here are other questions, pause the video and screenshot. And once, if you can do these 3 exercises, and we're able to understand everything I said, good people, I guarantee you that you won't have problems when it comes to interpretation of functions. It is that simple. All it needs is your time and constant practice. But since it is that time of exams now, obviously you shouldn't be studying. All you are doing now is just going through past question papers. So I hope you really enjoyed the video and I hope you understood. That is it from me. I hope the video helped. Thank you. All the best with your exams.